Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
If you jump off a cliff of height h and acquire a speed v at the bottom, and you're jumping from rest, so your initial velocity is 0, how high would you have to jump to acquire a speed twice that? So we know it's higher, but the question is how much higher? We don't know this distance. So if we express the height as a function of velocity, we can look and see what happens when we double the velocity. So I will put the 2v here. We want the speed to be twice as big in the second. So looking at the equation, v squared is equal to v naught squared plus 2a times the displacement, which in this case is vertical, so we use y. Velocity squared, 0 squared is 0, so I can leave that out. The acceleration due to gravity is g, 9.80 on the surface of the Earth, times the value given, which is height. So if I solve that for h, I just get v squared over 2g. So if we were to double the velocity here, if we plug in 2v, square it, divided by 2g, you get 4v squared over 2g. And v squared over 2g right here is equal to h. So the new height would have to be equal to 4 times the height that was originally jumped in order to get a speed that's twice as your original speed. Then the second part says, does we do this on a different planet? Does G 9.8? And as you can see, we haven't plugged in 9.8 ever. It's just a constant. And as long as it's the same for the first jump as the second jump, you haven't changed planets in between, then the acceleration due to gravity is irrelevant. The gravity, in order to make it, you don't need to have necessarily, you don't need to be on the Earth. So it doesn't matter.